crashing onto the buildings.
What was that? Sounds like the end of the world.
It's coming directly overhead. Should we go in here?
Yeah.
Oh, lights are on. We're home now.
The lights are on, but there's no one home.
There's a stairway that goes upstairs. Good.
To survive the night, John and Jeff need a place to shelter from the falling bombs.
Do you think there's going to be any alarms?
Well, I don't think so. Who's going to come in here to check?
Even inside the building, they are far from safe. The whole structure is being rocked by the force of each explosion. The vibrating window frames signal the strength of each seismic tremor.
Now, would you stay in that building that was making a noise like this?
If the volcano blew now, John and Jeff would be incinerated. Next morning, they realize the danger they're in. It's like being in a war zone. Jeff Mackley is determined to get the best possible shots.
Had a continual series of eruptions this morning. Every half hour or so, the vent, which is about 1 kilometre away from us, jets rock and ash to about 500 metre elevation. The sound of rockfall is quite loud. I think you can hear one behind me now. There we go. There's another one happening just as I speak. This style of eruption here is a jetting type eruption. It's gas generated. There's a shower of rocks and boulders crashing back down onto the side of the vent. There's another vent starting up. If this trend continues, the next vent will open up inside the town, and the one after that may open up level with the lake or under the water, and if that happens, we definitely would not be safe in this position.
Despite the great risk, they move even closer to the erupting vent.
We're probably about 200 metres from the bomb impact zone.
So we don't want to go too much closer, really?
I think about 100 metres is our limit.
Just as dangerous as the bombs, a boiling cocktail of volcanic ash and melted snow, called lahar, flows through the streets. These hot mud flows are only a few inches thick, but like a flash flood, they can turn into a deadly wall of water in seconds. They're already too hot and wide to cross.
Just watch out. How safe are we here?
If these flares are coming past our exit, then we've got serious problems.
Okay, I think we better get the hell out of here.
I can hear this stuff raging behind me. It's picking up, so let's go.
Yeah. No, we're just about to get cut off. There's another one right in front of us that's only just stopped here. It's pretty ominous.
No one knows John and Jeff are here. Rescue is out of the question. They decide to retreat.
Another eruption starting. 300 metres inside the main street. There's a lahar at the other end of the street. We don't even know if we're cut off at this stage, but we're making our way back and we've just got to try and get out.
Okay, we better go. Quickly.
That's what we're fleeing from.
No one knows exactly when, but scientists still believe a catastrophic eruption will happen. Predicting explosive volcanoes like Uzu is almost impossible. It could be 100 years, or it could be tomorrow. John and Jeff escaped. 6 months later, the town of Toyako Onsen is still empty, and Mount Uzu is still waiting to blow its top. This volcano's activity has also increased dramatically, with major eruptions as frequent as every 4 days. This is Mount Etna, on the Italian island of Sicily. At over 10,000 feet, it's Europe's biggest and most active volcano. French scientist Patrick Allard is head of geochemistry for System Poseidon, a group of scientists responsible for predicting Etna's eruptions. They constantly monitor Etna's summit craters. Recently, the southeast crater has been erupting huge fountains of lava high into the air. Over 1 million people live around the base of Etna. Every few years, lava flows reach and destroy their homes. 12 miles from the summit, in the city of Catania, is System Poseidon's nerve center. These antennae collect data from 39 seismic sensors spread around the volcano. Inside, drums record tremors set off by gas bubbles released from the magma as it rises inside the volcano. It's the year 2000. Etna is producing more tremors than ever before. System Poseidon is expecting some large eruptions. On the morning of June 8th, an unusually strong signal is detected. Patrick Allard races from Catania to the summit, just 2 hours after the warning an eruption begins.
We're now towards the summit part of Etna, and we observe that an eruption has been starting for about half an hour, 1 hour. And this eruption is still increasing in power and explosions. Lava flow starting, no, lava fountain. Yeah! Look at that.
Hot magma rises from deep below the volcano to the surface because it's less dense than the surrounding rocks of the Earth's crust. Inside is a labyrinth of tubes and fissures. The magma forces its way up through any weakness in the volcanic superstructure. Explosions smash the magma into thousands of lava bombs, throwing them hundreds of yards into the air. In just a few minutes, the force of the explosions is greater than anyone had predicted. This eruption is rapidly turning into one of the most spectacular ever seen.
You can see the lava fountains running up to more than 300, between 300 and 500 meters high above the Starfish crater. You can hear the sound of the eruption, a roaring sound. Jets of gas coming from the bottom, from depth in the magma reservoir, and jetting the bombs high above the volcano. The bombs are falling above on the cone and makes this grey, yellow ash falling down the slopes of the cone.
The lava bombs pounding the ground create a cloud of hot ash and gas. Allard and our film crew are less than half a mile away, in great danger if this superheated cloud shifts direction and comes towards them. Luckily, the cloud descends down the far side of the cone.
You can see the lava fountains jetting over 600, 700 meters high, maybe 800 meters high, and the huge bombs coming down. Absolutely spectacular.
The lava that gushes out of Etna is over 1,800 degrees Fahrenheit. Mount Etna started erupting 500,000 years ago. In that time, it has poured 10 cubic miles of lava and ash onto the surface of the Earth. Each day, it belches out 50,000 tons of gas, including sulfur dioxide and carbon dioxide, into the atmosphere. The force of the explosions is so powerful that blocks the size of cars are blasted out of the crater. Within just 10 minutes, the eruption reaches its climax. It's turned into the largest ever filmed on Etna. Etna is a rare volcano. Its lava is pure basalt, uncontaminated magma that has risen from as deep as 60 miles below the Earth's surface. The Earth is full of radioactive elements. They produce heat and cause parts of the solid interior to melt and then rise to the surface. The Earth is literally letting off steam as heat trapped inside tries to escape. Each eruption allows just a tiny fraction of that heat to escape. In the volcanic plume, there are millions of tiny lava particles known as tephra. These can be carried great distances by the prevailing winds. Like asbestos, when they're inhaled, they're extremely harmful. If the volcano blew now, John and Jeff would be incinerated. Next morning, they realize the danger they're in. It's like being in a war zone. Jeff Mackley is determined to get the best possible shots. Crashing onto the buildings.
What was that? Sounds like the end of the world.
It's coming directly overhead. Should we go in here?
Yes.
Whoa, lights are on. We're at home now.
The lights are on, but there's no one home.
There's a
Even inside the building, they are far from safe. The whole structure is being rocked by the force of each explosion. The vibrating window frames signal the strength of each seismic tremor.
Now, would you stay in that building that was making a noise like this?
stairway that goes upstairs here.
To survive the night, John and Jeff need a place to shelter from the falling bombs.
Do you think there's going to be any alarms?
Well, I don't think so. Who's going to be coming here to check?